Hello everyone and welcome to today's session on water treatment. I am Dr. P. Magesh Kumar from the Department of Civil Engineering, K.S.Rangasamy College of Technology. In this video, we will explore the journey of how raw and contaminated water is transformed into clean and safe drinking water. Water is essential to every aspect of life, not just for drinking but for sanitation, agriculture, industry, and recreation. However, the water available to us from the natural sources like rivers, lakes, and even underground aquifers is often filled with a variety of contaminants. These contaminants can be physical, chemical, or biological in nature. The goal of water treatment, therefore, is to remove these impurities, ensuring the water is safe, pleasant to use, and environmental friendly. Ultimately, it protects human health, supports industrial needs, and maintains the delicate balance of our ecosystem. Let's talk a little more about the different types of impurities we might encounter. Physical impurities, including sand, silt, debris, and suspended solids, these make the water appear cloudy and dirty. Next, the chemical impurities involve dissolved salts, heavy metals like lead and arsenic, and sometimes harmful chemicals introduced by the industries or agriculture. Biological impurities are particularly dangerous bacteria, virus, protozoa, and parasites that can cause severe illness like cholera and dysentery. Next, the dissolved gases like carbon dioxide and methane can affect the pH of water or even lead to odor problems. The organic pollutants such as pesticides, herbicides, and industrial waste products not only harm humans but also disrupt aquatic life. Understanding these impurities is crucial because each category demands a different treatment strategy actually. Next, the basic steps in water treatment. First, the treatment unit is screening, the first line of defense. Here, the large floating objects like leaves, plastics, and even dead animals are removed through mechanical screens. Next, the coagulation and flocculation. Tiny particles that don't settle easily are clumped together into larger aggregates called flocks, making them easier to remove. Sedimentation, the heavier flocks are allowed to settle naturally under gravity. In the filtration process, water passes through porous media to remove smaller particles and microorganisms. Next, the disinfection process, the final safeguard where chemical or physical methods are used to kill or inactive the pathogens. Each step progressively polishes the water, ensuring that the time it reaches the consumers, it is crystal clear and microbially safe. Next, coagulation and flocculation. In coagulation, we add chemicals like alum or ferric salts into the water. These chemicals neutralize the charges on suspended particles, causing them to stick together. Flocculation then follows, where water is gently stirred to encourage the formation of larger, heavier aggregates called flocks. These flocks are easier to remove in subsequent sedimentation steps. Without this phase, very fine particles would remain suspended in water, making filtration much more difficult actually. Next, the sedimentation process. Once flocks have formed, the water is directed into larger sedimentation tanks. Here, under the force of gravity, these heavy particles slowly sink to the bottom. Clear water can then be carefully collected from the top. Effect, Effective sedimentation dramatically reduces turbidity and decreases the load on the filtration units, making the entire process more efficient. Some treatment plants also use inclined plate settlers or tube settlers, we call it as, to speed up the sedimentation process in the limited spaces. Next comes the filtration, an absolutely vital barrier against the fine impurities and the microorganisms. The water passes through layers of sand, gravel, and sometimes activated carbon. Sand and gravel physically strain out particles. Activated carbon not only filters physically but also absorbs chemical contaminants and improves the water's taste and odor. Filtration system can be slow sand filters, rapid sand filters, or advanced membrane filters depending on the requirement. This step actually ensures that nearly all visible impurities are removed and biological contamination is reduced. Even after filtration, some microorganisms could survive. This is why disinfection is necessary. The chlorination is the most common method where chlorine gas or chlorine compounds are added to the water. Chlorine is inexpensive and provides residual protection, meaning it keeps working as the water travels through pipes to your home. UV radiation is another method which uses ultraviolet light to deactivate bacteria and virus instantly without adding chemicals. Ozonation uses ozone gas as a powerful oxidizer to destroy microorganisms and break down organic pollutants. Each method has its own strengths and limitations. In many places, a combination of method is also used for maximum safety and efficiency. Advanced treatment techniques. The reverse osmosis pushes water through a semi-permeable membrane to remove salts, metals, and even very small organic molecules. It's especially used for the desalination. Ultrafiltration uses finer membranes than sand filters and can remove viruses and bacteria. Activated carbon absorption is used to tackle taste, odor, and organic chemical pollutants. Membrane bioreactors combine biological treatment with membrane filtration to treat wastewater to very high standards, making it suitable for reuse. These technologies are critical in urban areas, industries, and water scarce regions. To ensure that treated water is genuinely safe, we rely on stringent standards and regular monitoring. In India, we refer to IS 10500 2012, which specifies acceptable limits for various water quality parameters. Internationally, the World Health Organization guidelines are widely followed. Routine tests are conducted to measure physical parameters like pH, turbidity, and chemical parameters like fluoride, nitrates, and heavy metals, biological parameters like E. coli and total coliform counts. These checks are vital not just at the treatment plant but throughout the distribution system actually. In summary, water treatment is a multi stage, highly engineered process that transforms polluted or raw water into a safe and valuable resource. As we move into the future, sustainable practices will become increasingly important. Emerging technologies such as smart sensors, AI driven process optimization, and decentralized water treatment units are already showing promise. Community participation, public education, and investment in affordable technologies will be the key to ensuring that safe water is available for all, especially in rural and unserved areas. Water is life, and through proper treatment, we ensure it remains a blessing rather than the source of disease. Thank you for your attention and time.